We are going to speak about Internet addressing. The Internet Protocol is the principal communication protocol of the Internet Protocol Suite TCP/IP. It is based in packet switching technology, and it is able to relay datagrams, that are data packets, across network boundaries. And that enables the Internet working function that supports the Internet as we know it, as the Internet is a bunch of different computer networks that are put together. Every device on the Internet is assigned an IP address. In the early 80s, when TCP/IP was adopted, IP addresses with 4 bytes, that is 32 bits, as every byte has got 8 bits, were used. Why? Because the number of possible different addresses, that is 2 to the power of 32, that is 4.3 billion, was considered a huge number that was more than enough. But with the rapid growth of the Internet after commercialization in the 90s, it became evident that the address space available with IPv4 was not enough to connect all the new devices that they envisioned in the future. So by 1998, the Internet Engineering Task Force had formalized the successor protocol, the IPv6, that uses 128-bit addresses that allow for 2 to the power of 128 addresses, that is approximately 3.4 by 10 to the power of 38 addresses, more than enough for what we have in the Internet now and in the long-term future. So we have 2 different IP addresses, IPv4 and IPv6. IPv4 uses 32 bits, that's 4 bytes, and its first version was deployed for production in the ARPANET in 1983. It still routes most of the Internet traffic today. It reserves a special addresses block for private networks and for multicast addresses. IPv6 is the other type of IP addresses. They are represented by 8 groups of 4 hexadecimal digits, that is 128 bits, and has a much bigger address space. The 2 protocols are not designed to be interoperable, what complicates the transition, but there are several mechanisms that allow an IPv6 host to communicate with an IPv4 host. So the complete transition from IPv4 to IPv6 was planned for 2012, as in 2011 the last IPv4 block was assigned. But several clever technical solutions introduced to connect more devices to the Internet, sharing only one public IPv4 address, have delayed. And in fact, most of the Internet traffic, as I said, is still routed by IPv4. All the major operating systems are able to use both types of addresses, but by July 2015, the percentage of users reaching Google services with IPv6 reached 8%. So this figure gives you an idea of how many traffic is still routed with IPv4. We have reached one host, but we need something more, because once we have reached one device connected to the Internet, we need a mechanism to reach the different applications and services that this host may be offering. For example, we can have a file server that's also a web server in the same machine, or in our desktop computer we can be using several Internet services, and the operating systems needs a way to send a message to the proper application once it is received. So for this, the concept of port was created. It is a logical construct to identify a service of application in a host. A port serves as an endpoint in an operating system for a specific service or application. it is associated with the IP address and with the protocol. Each port is identified by the port number, that is a 16-bit number that is attached to the IP address with a colon. Specific port numbers are often used to identify specific services. Of the thousands of different ports we can have, 1024 well-known port numbers are reserved by convention to identify specific services types on a host. We don't usually see this port number because every application is programmed to use a specific port. So when we type an IP address in a web browser, for example, it understands that the request will go to port 80 that we can see here by default. But we could have, for example, two web servers running in the same host and direct our request to the second host instead to the first one. So we would do that using a different port. For example, we would address 158.42.4.23 colon 8080. That's a different port instead of 80. This same idea is used in the client-server model application architecture, where ports are used to provide access to the same application to multiple clients. For example, we use a port that, to which the network clients connect for service initiation, and after that the communication is reestablished on another port that is assigned for each client.